Assalamualaikum warahmatullahi wabarakatuh. Hello, Ibu Mirna and friends. My name is Faiza Nazifa. And in this occasion, we will continue our topic about hyperbolas. But before that, we are from the sixth group, and let me introduce our member. There are Aulia Fitri, Eldana Rahman, and me, Faiza Nazifa. Okay, our topic for today is polar point and polar line equation of hyperbola. The previous meeting, we've already discussed about tangent line equation of hyperbola if a gradient is given and also a point is on a parabola is given and on hyperbola is given. And now we will continue our topic about tangent line equation of hyperbola if a point outside hyperbola is given. But before that, we have to know kind of a tangent line equation based on the position of a point towards hyperbola. The concept is actually the same with parabola that we've already discussed. That is, if a point is inside hyperbola, there is no tangent line. So if a point is inside the hyperbola, there will be no tangent line that pass through the point A. If a line is passed through point A, the line will intersect the hyperbola, not touch the hyperbola. So, and then a point is, if a point is on the hyperbola, there will be exactly one tangent line. So this is a point is on the hyperbola. So there exactly one tangent line that pass through the A point. And then the third one, if a point is outside the hyperbola, there will be exactly two tangent lines. So this is point A is outside the hyperbola. So there will be exactly two tangent line that pass through the point A. So the third condition will be our topic for today. So if a point is outside the hyperbola, there will be two tangent line. And also, and of course, there will be two tangent point. So if we connect the tangent point in this condition is K and L will be the tangent point. So if we connect these two points, that we call a polar line. So for the more explanation, we will look at this. If there is a point outside the hyperbola, which is A, with x1, y1, we can use these following steps to find the tangent line equation if a point of outside parabola is given. So the first one is we have to determine the equation of polar line. Line KL is a polar line. Polar line means a line that connect two a tangent point of a tangent line based on a line that a point outside the hyperbola. So we have to determine the equation of polar line, and in this condition is KL, that have the same formula with tangent line on A. We will discuss the formula of a polar line later. And then we have to substitute the equation of polar line into equation of hyperbola. So we got two tangent points. And then we have to determine tangent line equation of each tangent point. But in this condition, we have to remember when we face questions that gives a point, we have to check if the point is on a hyperbola or is outside the hyperbola. If a point with x1 comma y1 is on the hyperbola, so the equation is called tangent line equation. But if that point is outside the hyperbola, so the equation is called polar line equation. So the formula is the same, but the condition, the equation is different. So in previous meeting, we've already discussed if we have this kind of hyperbola equation, we will have a tangent line equation of hyperbola or a polar line equation of hyperbola like this. This is a horizontal hyperbola with center 0.0, and this is the uh, tangent line equation, and so on and so forth. You guys can see in this picture. Okay, so I already mentioned that tangent line equation and polar line equation have the same formula, have the same equation, but the condition is different. So how do we know what is the proof that how could be this two lines have the same formula, have the same equation? So look at this. Let we have this horizontal parabola, and we have point P is outside the hyperbola with the coordinate x1 comma y1, and then we will have exactly two tangent line as we've already discussed at the first section. So the AP is the first tangent line and BP is the second tangent line. So according to the definition of a polar line, line AB is a polar line since it connect uh, a tangent point that are a point A and point B. So the AB line AB is a polar line. All right? Do you get my point? And then tangent line AP, we just call a TLA. The TLA pass through A on hyperbola. So the equation is this, right? We substitute the coordinate of the position of A into the hyperbola equation. And since TLA also passed through point P, which is a point is outside the hyperbola, so the equation will be like this. We substitute the value of point A and also point P, and we got like this. Or we can change the form into this, and we call it the first equation. We just do the same thing as tangent line BP. We call TLB, BP. Since it's passed through B on hyperbola, the equation will be like this. And since TLB also through, this is B, sorry, this is point B, also through point B, and the equation will be like this, and we change into the same form of the first equation. Then we eliminate the first equation and the second equation, and we just do like algebraic way, and we got b square times x all over a square times y. This is the gradient of line AB. Since a polar point is kind of straight line, so the equation of line B is y minus ya equals m times x minus xa. This is the equation of a straight line equation that pass through two points. Since polar line is passed through point A and B, so we can use this kind of a straight line equation. And then we substitute the value of m that we got from this elimination way. Then we just do like algebraic form. I'm sure that you guys familiar and can do this way. And we got the final equation is x1 times x all over a square minus y1 times y all over b square equals 1. So this is the formula of polar line. Since we know that if we have a horizontal hyperbola with center 0.0, we have this kind of tangent line equation. And also the polar line equation is also the same. So we can make a conclusion that um, tangent line equation with polar line equation is have the same form, the same formula, but we just have to remember the point. So if the point is on a hyperbola, so we can get a tangent line equation. And if a point is outside the hyperbola, so we get polar line equation. And then we just do how to determine the tangent line equation of hyperbola is a point outside hyperbola is given. So we just do this following steps, and we got the tangent line equation from this by using these steps. So that's all for me. Thank you.
In this occasion, we talk about the conjugate hyperbole, or we can call the hyperbola sekawan. Before we talk about the conjugate hyperbole, we must to remember the element of the hyperbole. First is the horizontal hyperbole. The focus point is the f1 and the f2. And the fixed point is the p1 and the p2. And the center point is the 0.0. And the asymptote line is the a1 and the a2. And the real axis. Real axis is the line that connect the both of the fixed point. So the line is connect the p1 to the p2. It's called the real axis. As we can see, the real axis is the part of the x-axis. Next is the imaginary axis. Is the line that connect the point A to the point B. So it's called the imaginary axis. The imaginary axis is part of the y-axis. The other element of the horizontal hyperbole is the small a. The small a is the half the length of the real axis. So the small a, the a kecil itu adalah setengah dari panjangnya real axis. Jadi ini merupakan a kecil, dan small b is the half the length of the imaginary axis. So this is the small b, and the small c is the distance from the center point to the focus point. So this is the small c. Next is the vertical hyperbole. The vertical hyperbole is same as the horizontal hyperbole, but the difference is the real axis and the vertical hyperbole is the part of the y-axis. And the imaginary axis of the vertical hyperbole is the part of the x-axis here. And then the a, small a, in the vertical hyperbole is the half the length of the imaginary axis. So this is the small a. And for the small b is the half the length of the real axis. So this is the small b. Next is the c. It's the distance from the center point to the focus point. So this is the small c. Mungkin bertanya-tanya kenapa jarak dari sini ke sini itu bisa dikatakan small c, c kecil, karena jika kita menggambar lingkaran dengan pusatnya di 0,0 dan melewati melewati focus point, jarak antara the distance between the center point to the focus point is the radius. So, jarak dari titik center point ini ke semua titik di circle ini sama. Jadi kita bisa membuat jarak dari sini ke sini itu small c. Sehingga kita mempunyai segitiga dengan siku-siku di B, sehingga kita bisa menggunakan rumus teorema Pythagoras, yaitu c square equals to a square plus b square. Next is the conjugate hyperbole. Conjugate hyperbole is a two hyperbole whose center point is the same. Then the value of the small a, small b, and the small c is the same, but only different in the type. One is horizontal hyperbole and the other is the vertical hyperbole. So here I want to try to show that hyperbole x squared over a squared minus y squared over b squared equals to 1 conjugate with x squared over a squared minus y squared over b squared equals to minus 1. So here saya sengaja membedakan warnanya, yang red one for the horizontal hyperbole and the blue one for the vertical hyperbole. So we can draw the graph like this. For the horizontal hyperbole, we can draw the graph like this and like this. With the fixed point is the P1 red and the P2 red, and the focus point is the F1 red and the F2 red. With the direction line, this and this, with the equation x equals to plus minus a square over c. And for the horizontal hyperbole, we can graph the and the vertical hyperbole, we can draw the graph like this. So with the focus point is the F1 and the F2, and the fixed point is the P1 and the P2, and the direction line this and this. With the equation is y equals to plus minus b square over c. Dan untuk asymptot untuk kedua hiperbola itu sama dengan equation y equals to plus minus b over ax. So if we draw the rectangle and the circle, so we can see the difference between the vertical hyperbole and the horizontal hyperbole. For the vertical hyperbole, the real axis is the line that connects the P1 blue to the P2 blue. And this is the real axis. And for the imaginary axis is the line that connects to the P1 red to the P2 red. So this is the imaginary axis for the vertical hyperbole. Next, for the horizontal hyperbole, the real axis is the line that connects the P1 red to the P2 red. And the imaginary axis is the line that connects the P1 blue to the P2 blue. So this is the real axis and this is the imaginary axis. Nah, dari sini kita tahu bahwa kita dapat simpulkan bahwa the value of the small e, small a, small b, and the small c is the same. So we can conclude that c square equals to a square plus b square. Next, for the hyperbole that center at alpha, beta. Hyperbole x minus alpha all square all over x a square minus y minus beta all square all over b square equals to 1 conjugate with x minus alpha all square all over a square minus y minus beta all square all over b square equals to minus 1. The principle is the same as the one in the conjugate hyperbole whose center 0.0, but now the center at alpha point beta. So caranya itu sama kayak yang di hyperbola dengan center 0.0, dengan yang warna merah itu the red one is the horizontal hyperbole and the blue one is the vertical hyperbole. Then if we draw the rectangle and the circle, now is the difference between the vertical hyperbola and the horizontal hyperbola will kita bakal bisa melihat perbedaan antara horizontal hyperbola dengan vertical hyperbola. Untuk yang vertical hyperbola, the red axis is the line that connect the P1 blue to the P2 blue. And for the imaginary axis is the line that connect the P1 red to the P2 red. So this is the real axis and this is the imaginary axis. For the horizontal hyperbola, the real axis is the line that connect the P1 red to the P2 red. So this is the real axis. And for the imaginary axis, the line that connect the P1 blue to the P2 blue. So this is the imaginary axis. And this is the value of, and this is the A, B, and the C. Then we know that the C square equals to A square plus B square. And for the conclusion, the real axis and the imaginary axis of the conjugate hyperbole is the switches. If the horizontal hyperbole is become the real axis, and the vertical is become the imaginary axis. On the other hand, if it's the real axis in the vertical hyperbole, then it will be the imaginary axis in the horizontal hyperbole.
And now we will talk about the problem examples. So the equation is determine the equation of the tangent line to the hyperbola x square minus y square equal to 16 from the point 2.0. And the first steps we need to divide the equation with 16, and we got the x square over 16 minus y square over 16 equals to 1. And the next step, we need to determine whether a point is inside, outside, or on the parabola. The point can just substitute into the equation of the hyperbola, and we got the 1 over 4 is less than 1. And if the hyperbola is horizontal, we know it is a horizontal hyperbola, right? And the substitution result shows that the left hand less than the right hand side, then the point is outside of the hyperbola. And the next step, we need to find the polar line. We already know the equation of the polar line. It is x1 y x1 x over x square minus y1 y over b square equals to 1. And this is x1 and this is y1. And x1 is 2x over 16 minus y1 is 0, 0 times y over 16 equals to 1. And we got the equation of the polar line is x equals to x. And next, from the polar line equation, we can find the tangent point. Untuk menemukan titik singgung, we just need to substitute the equation of polar line into the equation of hyperbola equation. And yep, x squared it is 64 over 16 minus y squared over 16 equals to 1, and blah blah blah, and we got the y equals to plus minus 4 root of 3. So the tangent point is x point 4 root of 3 or x point minus 4 root of 3. And after we got the tangent point, we can find the tangent line. Oke, kita tahu kalau rumus dari tangent line is this x1 x minus a square minus y1 ay over b square equals to 1. Bagaimana caranya? Kita hanya perlu mensubstitusikan, we have to substitute the tangent point into the equation of tangent line. It is x1, x, it is y1, and yep, we substitute x8 over 16 minus y1 over 4
root 3 over 16 equals 1. And kita kalikan kedua ruas dengan 4. And we got the tangent line equation is 2x minus root 3y equal to 4. And what about the tangent point dengan titik 8,-43? Kita melakukan hal yang sama seperti sebelumnya dengan mensubstitusikan tangent point into the equation of tangent line. This is x1 and this is y1. And x1 it is x over 16 minus, and this is y1 negative 4 root 3 over 16 equals 1. And we divided kedua ruas dengan kita kalikan kedua ruas dengan 4. And we got the equation of the tangent line is 2x plus root 3 y equals to 4. Dan dari melakukan hal tersebut kita telah mendapatkan dua persamaan garis singgung.